This is the second webinar we are running from the energy sector series called Powering the Future. A welcome back to anyone who attended our previous webinar, How to Make Energy Interesting, and a very warm welcome to everyone joining us for the first time. And welcome and thank you to Andrew Keane, who is our speaker today. Hi, Andrew.
Hi, thanks very much, Bena. Thanks for having me along to present.
Pleasure having you. So before we move on to some introductions very shortly, I would like to first give a quick overview of the format of the talk. So the first part of the webinar will be Andrew's presentation, and then we have saved some time for Q&A at the end. There is a Q&A option in Zoom, so you can post your questions there and even upvote the ones you find most interesting. If you want to make a comment, ask a question, or share your experience by talking instead of typing, you can also use the option raise your hand through the bottom of your console, and we'll allow you to speak as soon as possible. Moving on to some short introductions. My name is Albena Krosteva. I am head of growth at Zartis, and I will be the moderator for this talk. To give you a short background on Zartis, we are a software services company with 100+ engineers distributed across Europe. We help companies improve the way they build software and get applications built in a faster, better way through providing nearshoring, extended development, and consulting services. As a company, we have extensive experience in building software solutions for the energy and renewable energy sectors. And the purpose of this series of webinars is to learn from the community and the insights shared by our speakers and all of you as attendees. I am very happy to present our speaker today, Andrew Keane, CTO and co-founder of Novogrid and director of the University College Dublin Energy Institute. He has extensive expertise in the energy sector and a very unique insight coming from a blend of academic and business experience. Novogrid offers software solutions that enable renewable generators to reduce the cost of delivering their energy production to the electricity grid by providing real-time network visibility. Their patented software solution called Grid Boost provides owners and operators of distributed generators with the ability to maximize the output from their plant by moving away from fixed modes of operation to smarter, more efficient modes. With that, I will give the floor to Andrew for what I'm sure is going to be a very interesting presentation.
Thanks, Albena. Thanks for the kind introduction. Good afternoon, everyone, and thanks for joining the webinar. I hope to be able to share some points of interest and for discussion. I've kind of deliberately set this up to be maybe somewhat provocative in terms of the view I'm taking in terms of the future of things, but let's explore that as we go. So in terms of what I'll talk about, I'll talk briefly about Novogrid, a little bit of the background, but then quickly get into some of the emerging trends as I see them, how that relates into the evolution of the energy system, particular focus on the electricity system, perhaps self-evident from the title, and then look at what I see as potential paths forward as things move on. And of course, the whole context here is of course the energy transition. Just in terms of Novogrid itself, so we were founded in 2014 by myself, Paul Manning, and Peter Richardson. And I guess the early stages of the company was a lot of product development, a lot of R&D, but in recent times, happily now, we are very active in the market, particularly in Ireland and the UK. Our underlying philosophy of the company is really around elegant software solutions and solutions that can operate autonomously and without reliance on communications. And you'll probably get a sense of that as I present. We have a couple of products, Grid Boost, Grid Flow, and Grid Trade. And I guess just to give a sense of who we work with, ESB Networks, the Irish distribution system operator, Scottish and Southern Electricity, EDIS are a German DSO, ESB's kind of UK generation arm, and also Foresight Group, among others. And we have live grid installations in Ireland and the UK. That's all lovely. Here's some pictures maybe which might give you a better insight to who we are. So that's Brendan and Peter on the top right-hand corner there. And the box on the left is our existing RTU Motorola unit, which we use to house our software. solutions, complete with our old brand. So someone will get out to me for that afterwards, no doubt. So we install our solution directly on the wall of wind farm substations and connect into the SCADA system, and then drive the efficiency benefits that we can provide from there. And we've enjoyed our collaboration with Zartis over 2020, where we've been really looking to and successfully have kind of replicated or moved a lot of the functionality on the hardware on the wall there up to the cloud, to a cloud-based solution using AWS. And I think we've enhanced some of our software efficiency along the way from the work with Zartis, which has been really beneficial for us. So just moving on then to the talk proper. Look, the context for all this is very much a European Union, EU approach, and also, of course, the UK. And in that way, you know, that the drive towards decarbonisation is pretty much taken as a given here. And I think Europe are certainly taking the lead in this regard internationally. And what that means really is, well, the ongoing integration of renewables, on which, in terms of electricity, we've achieved quite a lot, certainly in Ireland and indeed across Europe in a lot of countries. And also, as I talk about, and at the core of my talk here today, is the interplay between the integration of renewable energy alongside the increasing electrification of particularly heat and transport. And I'll get into that a little bit more as we go. So probably familiar to several of you, but like just to give a sense of the European Commission, the European Green Deal and the announcements by Ursula von der Leyen, continually showing the increasing ambition and the raising of the bar in terms of achieving kind of, I guess, net zero carbon by 2040 or 2050 is the ultimate goal, but trying to define a pathway to that along the way. So we have this European Green Deal, which talks about making Europe climate neutral by 2050. And while the European Commission then sets that at the European level, that is reflected down at national level by complementary action plans. So I'm speaking to you from Dublin, and we have a climate action plan as of last year, and that is a rolling plan towards 2030 to achieve, to make significant progress in terms of our decarbonisation of our system over here. And as I said, when our climate action plan in Ireland, and I think it's similar elsewhere, is really electrification of energy demand, particularly heat and transport, accompanied by large-scale integration of renewables. And those renewables, when we talk about it, certainly in Ireland's case, being on the kind of western edge of Europe, it's a lot of onshore wind. It'll be increasing amounts of offshore wind, some solar PV, as in the resource is not as bad as you might expect it to be if you're not from Ireland, but very much it's a story of wind onshore and increasingly offshore in the Irish Sea as we go forward. So that presents, of course, an infrastructural challenge. You need the wires, you need the infrastructure there to accommodate these renewables. But equally, if you shift a significant portion of your energy demand from transport and petroleum, basically, into electric vehicles, that is something you're going to notice, and the electricity infrastructure will require some investment to accommodate that. And again, we'll talk more about that. Something that flows from that then is actually the question of security of supply and the importance of it. So if as a society, we rely on, and already we are completely dependent on electricity, of course, but if you then have electric heating and increased prevalence of electric transportation, the security of supply or the value of lost load, as we might talk about in the sector, only increases, which maybe heightens and sharpens the focus on that infrastructural challenge, on the resilience of our energy systems. Before I go any further, I will also maybe just give a nod to, while I talk all about electrification here, if you think about net zero carbon, electrification is the right thing to do, and it will make progress on these issues. But even looking beyond 2030, you know, there will be a need for, let's say, molecules, as some of my colleagues would say, and the role of green hydrogen or superconducting technologies or other technologies and other energy vectors still have a huge role to play when we keep our eye on that ultimate prize of net zero carbon. But having said all that, there's a lot to be done and a lot of challenges to be addressed as we kind of head towards 2030 and try and make some progress. So you can kind of summarize all that as, well, we want more renewables and we also want electric heat and transport. And as perhaps a bit of an understatement to say that, well, renewable energy complicates the management of the grid, and I'll talk more about how I see the grid as we go here. And these challenges are well flagged and several of them have been well addressed. And I don't say this to kind of undermine renewable energy or wind energy, and they're absolutely addressable, but let's just recognize up front that it does make life more complicated for grid operators. And equally at a local level, if you start to place significant increases in demand for your heat and your transport at a local level, that can complicate the local network and the local energy network. So the energy networks on your street where you live, basically, is what I'm talking about there. But vital dimension to all this is that actually we need demand flexibility to support the renewables. So while the electric heat and the electric transport can present local network issues to be managed, they also hold an opportunity, as I'll talk about, to actually facilitate the continued renewable integration. And at the core of any energy system or the electricity system is this interplay between supply and demand. And fairly uniquely with the physics of an electricity system, it's an instantaneous balance that's achieved at every millisecond and second. And I'll talk a little bit, I won't get too much into electrical power engineering, but I'll just give a little hint or a nod to some of the physics at play. So just giving an example here of a recent article or press release from UK Power Networks, one of the UK network operators in kind of southern England. And there's a project, there's lots of exciting projects going on where they're looking at utilizing renewable energy to provide more support into the system and to have this end-to-end trial of this market. I'm not flagging this is like an amazing project. It may or may not be, but it was just one I came across this week, and anyone who's really active in the sector will be seeing these kind of articles the whole time. So it's a really active space, and there's a lot of really good activity going on, and I think a lot of people are addressing the challenges. What I'll immediately say is this question now of the language barrier. So I'm steeped in this stuff for better or worse, I guess. But like maybe any of us in our sectors or in our disciplines, we find kind of complicated ways, lots of acronyms and multiple ways of saying the same thing. And I would also imagine that sometimes they often just sound completely meaningless to people not in the industry. So some examples would be the DNO to DSO transition. So if you're in Britain and you mention DSO, that means something. Oh, we're doing the DNO to DSO transition. And that means that they're moving from an old network operation mode to more active system operation. So I've learned over the years that when I go over there and I mention DSO, I have to be careful that I say DSO or DNO. I don't think anyone else, anywhere else, certainly not in Ireland, maybe has the same significance attached to this, but you can see that the language can adapt even from country to country. People talk about active network management. I would talk myself about active network management, proactive network management, smart grids, intelligent grids. I mean, there's just no end to this stuff. So I guess I want to, in my talk today, maybe try and push through some of that and just kind of go maybe back to basics and build up a picture of what the system really looks like. So if we think about what the electricity system and consider, well, what's the underlying system architecture? Like we have a set of wires, circuits, complex infrastructure, generally utility owned, funded by electricity customers. So we've all paid for this network to be built, and we have transmission system operators who manage the high voltage grid, and the distribution system operators that manage kind of the more lower voltage, the more local networks. And I guess as I'll talk about, the action is really all happening at DSO level. The nature of these organizations is, well, their job is to keep the lights on, and they do a really good job at it by and large. And the reason they do a good job at it is because they are prudent. So they follow a prudent system operation mode. Some would say conservative. I decided to be more diplomatic here and say prudent. But crucially, and most likely correctly, they're not commercial entities. So as we go through this, you'll see that actually, a lot of the solutions will need to be provided by commercial actors. The view from Europe is around a market-driven approach and new designs of energy markets, new types of energy markets. So there is at play here a kind of an intersection between these non-commercial, regulated entities or system operators whose job is to keep the lights on, but the fact that the infrastructure they're managing is vital to the facilitation of renewables, the electrification of heat and transport, and the management of those in real time to facilitate each other and achieve decarbonization. And that can cause maybe issues, let's say. I was hesitant about including this slide because I wasn't sure exactly who the audience were. So this will either be patronizing you or boring you or confusing you. So you can tell me afterwards. But just when people talk about electricity and energy, if you're not an electrical engineer, I think you imagine perhaps that it's just about power. But the reality of the system is that we actually have AC, alternating current, 50 hertz sinusoidal waveforms at every instant in the sockets in your room. And the other physical reality beyond that is that the shape of that sinusoidal waveform there is directly linked instantaneously with the speed of rotation of the turbines in the conventional fossil fuel power plants, and the gas plants or the coal plants or whatever you have in your country. So it's a really complex system. It's one of the most complicated, complex man-made systems ever devised. It works really well. It's an amazing feat of engineering. But when we then go to look at kind of having this active network management or trying to facilitate these new market players, sometimes the physics behind this can get in the way. And in particular, and I've just shown there beside my little animation, thanks to Conor Murphy for this one, that actually what it gives rise to is not just watts and power that we understand, but also this reactive power, which is another component to power that we don't really talk about too much, or you do if you're me, I suppose, which is a very real physical phenomenon, and it's related to the conductor properties, the distance, the type of load, and these are the questions and the parameters that the system operators need to manage. So there are good reasons here, I guess is what I'm saying, behind why these system operators are prudent, because there's some complex physics at play, a massively interconnected system, and that all needs to be managed in real time. So complex physics is one point I'd make there, and then this kind of just indicative schematic is just to give a sense of the scale and vastness of the distribution network. So I looked up some stats in preparation for the talk. So Ireland, a small island, has 6,500 kilometers of transmission power lines or cables or thereabouts, but the distribution network in Ireland has about 170,000 kilometers of distribution network lines and cables. So like a massively more vast and longer network reaching down into everyone's meter in every home, apartment, commercial business, and whatever, right across the country. And of course, what's happening now is, well, we're having some wind, we're having PV, we're having lots of renewable sources integrating onto this network. And then I've just used EV as an example, but please take it to represent, the range of new resources that are connecting. Many new sources of uncertainty and many new opportunities, I think, for management. And it's all happening at the distribution network. So the story of historical power systems, as you may know, is the transmission system, a couple of large centralized stations, and the power just went down to the customers. That's gone. It's almost long gone at this stage, and it's only going. That trend is only going to continue. So we've got the complex physics, we got the scale of the distribution network, and then we have these new sources of uncertainty. So the management of this network is becoming increasingly complex. And then you introduce probably the most complicated factor of them all, which is the human element, right? The citizen. And I think really interestingly here, when you think about it, is that, well, the changes to the network are being driven by the consumer and by the citizen. So whether they're buying them in wide scale, yes, if you look at any of the trends, EVs and plug-in hybrid vehicles, in terms of just take cars again, if you'll allow me, are on the upward trend. I've been a believer in electric vehicles for about 10 years. It looks like maybe I'll be right eventually. But these are consumer decisions, right? That's the real point I'm making here. That in Western society, we don't get a mandate from the government. Maybe there's grants, maybe there's relief on motor tax, but consumers make consumer decisions and will decide to buy or not buy a vehicle, a heat pump, PV panel on their roof, storage, and so on and so forth. So the power is not within the hands of the system operators here, but the consequences of these consumer decisions perhaps need to be dealt with by the system operators. Really significantly, in my view, is that embedded in most of these, or in a lot of these, and I'm going to stick with the vehicle here, is significant computational resource or capability. If you think about the computer that's in a Tesla vehicle or any modern vehicle, it's fairly significant, and it's capable not just of attempting to do full self-driving or autopilot or whatever they're doing, but could indeed be used to maybe help manage the grid, or more pertinently, I think, provide a commercial service for either the car owner or perhaps someone who wants to manage that vehicle on behalf of the customer. So all this complexity, right, might give rise to a traditional power system approach, which would be command and control. Sometimes engineers are accused of just trying to do this command and control approach, and that will work. And really, if you think of the scale and all that I've talked about, while you can simulate this possibly, to actually centralize all the decision making back to a single control center, in my view, is basically undeployable. At best, not the most efficient path forward. Now that's, I guess, up for discussion, but in my view, it's just not sensible. One of the points I haven't mentioned here is that these distribution networks are sparsely instrumented, not generally monitored that well, and the amount of real-time information available from them is really limited. Advanced metering, or smart meters as they're more commonly known, might plug this gap a little bit, but whether that's going to be provided in real time and who can access that data, it remains to be seen, I would say. So my view is that the centralized kind of paradigm is just not a runner here. And then we really need to think, well, actually, it's great to do simulations, but what are the applications that we actually need for the energy system? And I'll hone in here again on the demand side. And there's a lot of players active in the space. Grid Beyond here in Ireland, NLX are another one that I would know, and there are several more besides who probably I should mention, but can't quite recall. And they are providing maybe energy trading. They're providing the system services that the system operators need to support the integration of renewables. I put network management there in brackets, obviously deliberately. I'm not a great believer in using demand side to actually support network management. Again, we can talk about that. And there's also a need for, well, if these networks are pretty instrumented, to provide some status in real time as to what the state of that network is. Also, you can improve the efficiency, and there are more basic network management functions that can be carried out around congestion management and so on. But I really view the demand side, the top few points there, as being really critical here, or crucial to the development. And how I would see it, and I've kind of just decided to take license to just put forth my view here, and for better or worse, is that really what we need is not that centralized approach, but is actually to utilize the resources inherent, the computational resource inherent within these type of resources is significant, and to have local, fully decentralized, kind of autonomous solutions that are driving the provision of these services, that are providing insight into energy trading, that are providing everything that the network and the system needs overall in totality, but without falling back into kind of this kind of command and control for the reasons that I just don't believe it to be particularly practical, let's say. So it's kind of autonomous. So in a way, then you are somewhat sidelining perhaps the distribution system operator or the transmission system operator. And again, this is just a personal view, but I kind of think that's probably already happening. I think if you are, I'll stick with Tesla, if you are Tesla, and if there was more, not everyone can buy a Tesla or whatever, but if you have a network of vehicles, Tesla know what the state of charge is in real time. They have huge data in terms of when people are charged. I mean, there's just a huge quantity of data available to them. So it would, to me, would make complete sense that they would look to utilize that. And I've heard senior people associated with Tesla talk about the distributed utility. They obviously know that that opportunity is there. And again, if you think about it, as electricity consumers, we turn on and off our lights, we do what we want, we don't have to check, we don't do it in response to something, we just carry on with our control of our demand. It may be kind of obvious to say that, but again, I don't see that a massive central oversight of the management of these vehicles or the provision of services or trading on not just vehicles, but from other flexible demand is something that's really going to be realistic. And I think it can be viewed in a more positive light, perhaps. So in terms of what I mean then by this distributed utility, it is this fact that I think, there are new stakeholders, new actors, and you'll see this reflected in European legislation whereby people can access the energy market. I don't view it as being like that I or you would individually do this, because most of us don't really care too much. Maybe I do, but I'm probably a special case in this regard. I will add, of course, well, if the network burns down, well, then we certainly all lose. But I kind of feel that can be managed, and that actually, there's scope to integrate a degree of network awareness into the kind of control decisions that demand aggregators or whoever would take when managing their fleet of flexible demand. In a way, it's happening already. I think it's only going to continue. And I think if you look at, if you look at the targets and look at, well, this says we're going to have hundreds of thousands of electric vehicles, solar PVs, widespread batteries, whether you believe we're going to have it by 2028, 2030 or 2031, I personally believe it is going to happen, and it's an inevitability, I think. And the fact that, we need those resources and that demand flexibility to actually support the fundamental point, which is to get more renewables onto the grid, and renewables with their degree of unpredictability, certainly uncertainty, that there is a huge opportunity here. And I view really that opportunity will be capitalized upon not by system operators, but by commercial entities. And nor do I think that system operators maybe particularly want to do it. They certainly want to ensure that the lights stay on, as they say. But in that way, I kind of see, as I say on my final point on the bottom of the slide there, that these new resources, the new opportunities presented by them, the fact that, as I say, there's significant computational capability embedded within that, means that really a lot of this can probably happen with minimal reference to traditional network operators or individual customers. And I just think that's an interesting scenario to play out. And I just thought, when I was thinking about presenting today, I said, well, I'll maybe make a pitch for that and see what people think. So I believe that is the end of my presentation. So thanks a million for your attention. I'm happy to answer any questions.
Thanks, Andrew. That was very, very interesting. Just a quick reminder for all of our attendees as we're entering the Q&A section of this webinar. There are two ways to ask a question. So you can type in your question in the Q&A option inside Zoom. It should be somewhere at the bottom, or you can also raise your hand if you want to speak, and we'll give you the floor. Yeah, please submit your questions. Andrew, I suppose kind of one question to start with. How has the COVID crisis that we've experienced this year, how has it impacted the trends you've discussed, and in what ways?
Sure. Yeah, well, I think. Sorry, my headset battery was giving HP there. I think it's interesting in that I think if you look at it, well, obviously COVID has captured everyone's attention, understandably so. I don't get any sense that there's any, deviation from the recognition that we need to kind of address the climate crisis, let's say. And I think if you look at the trends, even just I'll talk about vehicles again, the trends are only upwards in terms of the adoption of electric vehicles. So I think the industry has continued to follow its path with the same degree of urgency, obviously in a different manner. If anything, the COVID crisis and the effective shutdown of national economies almost, and the knock-on effect on emissions, I think maybe just gave people pause for thought around, the impact of our behavior. I'm not advocating to shut down the economy as a way of addressing climate crisis, but I think it's kind of continued at pace, and I think you'll see that. You've seen that from Ursula von der Leyen's, recent announcements.
Awesome. I see a bunch of questions coming in through the Q&A. The first one from Andy: do you see an opportunity for micro and smart grids to develop in Ireland? It seems a sensible conclusion from your talk.
Sure. No, thanks Andy for the question. So yeah, so again, I think with microgrids in particular, I think I always ask, well, what's the application? Like, what's the point of the microgrid? The power system itself is such a reliable and has been an instrument for massive social transformation, certainly over the 20th century. And it's so reliable that if you mean microgrids to be kind of islanded operational grids separate from the physical grid, I wouldn't be an advocate for that in most instances, because I think, you're disconnecting from the main grid doesn't make sense. The idea, though, of kind of positive energy districts and local energy coordination within communities, maintaining that mains connection to the grid, I think makes a degree of sense. But I do think it's, well, my view would be it's more likely to be kind of demand aggregator, commercial players that will make that happen. But there's been some nice demos done, not just in Ireland and elsewhere on that. So I'm a big believer in maintaining the connection to the grid, but more local coordination and positive energy districts. I think there's great opportunity there.
Awesome. Another question and comment coming from David. Great talk, thanks. Would autonomous or distributed approach, de-autonomous or distributed approach you propose, would it work similarly to smart intelligent grid?
Sure, yeah, thanks, David. Yeah, I think that maybe they're almost, the autonomous or distributed approach I'm talking about is almost just a different flavor or different version of a kind of a smart grid type concept. I think when this kind of smart grid thing took hold, I don't know, it's a couple of years ago now, I think it was that all-seeing grid with lots of sensors, and there will be more sensors. I just think if you push things at our natural conclusion, which hopefully came across when we talked, that just the scale and the complexity means that there will need to be a degree of kind of autonomous solutions out there. I mean, if I kind of deliberately presented kind of a purist autonomous approach, maybe the reality will be some blended approach in that, you know, control centers will still, of course, have enhanced capabilities. But that, I think there's a distinction between the keep the lights on, you know, maintain network security function versus the kind of the commercial provide the services to support renewables integration. So I think maybe autonomous is just a different version of the smarter intelligent grid.
Very good. And one follow-up question from David, how feasible in the short term would it be to achieve this autonomous distributed grid? In 10 years, 20 years, for example?
Well, yeah, that's a good question. I think it's probably more, you know, over the next 10 years that I don't think it's a, let me say, how can I put this? I don't think it's complete transformation, but I think we will see it happen step by step. I think you will see that, then, as I say, the need for that demand side flexibility is only going to increase. And I think that will be the driver for more of these kind of, you know, autonomous and distributed approaches. And in a way, I think they're probably happening already, just that we don't really realize it, and that there's demand aggregators now operating in the market who have, you know, communications down to the demand side, and they're controlling these devices the whole time. And maybe the system operators would like more oversight of that. And I think that's probably a discussion that's ongoing at the moment. My view is that that discussion will just be overwhelmed in time by the sheer quantity of these kind of resources and devices, I suppose. So I think over the next 10 years, we'll see a huge transformation, David.
Awesome. One more question from Andy. What further legislation is needed to ensure a drive to zero happens, or should it be left to markets to deliver?
Oh yeah, that's a tricky question. So as I said, like there's, you know, the European Commission, there's huge impetus there. I guess I know most about the Irish situation, and we've recently increased the carbon tax. So I mean, I think that is a sensible step. So I think we will need more and more of that. I think we need probably stronger enforcement of clean air initiatives. You know, certainly in the Irish case, solid fuel still used quite a bit for heating homes. So I think there's a mix of legislation and things like instruments like carbon tax to actually drive this along, alongside maybe kind of incentives and subsidies. You know, electric vehicles are still expensive. So, you know, it's not going to achieve mass market participation, I think, at current price levels, I would suggest.
Fair enough. Another question from Bo. Do you think a smart grid will make us more vulnerable to cyber attacks?
Probably yes. I think that's probably true. And I haven't looked in detail at the, you know, how the distributed or autonomous approach would be more or less vulnerable. Maybe it's more vulnerable to individual attacks, but maybe because it's more distributed, you know, the overall whole is more secure. So I'm hesitant to offer a deep answer to that, because I don't think I really know, but I think certainly cybersecurity in general of the energy system, whatever way you look at it, is an increasing challenge, and there have been noted cyber attacks on energy infrastructure for sure. I don't think they get talked about too much, but there have been significant ones. But I'm not an expert in cybersecurity, so that's probably the best I can do on that question.
Very good. A question from Diana. To what degree do you view the data collected by new market players such as Tesla key to the success of a distributed system?
Yeah, I think it's really central actually, and that's kind of when I was thinking about this or have been thinking about it, I always, maybe whatever reason they're in the press, I think about them a lot, or you hear about them a lot. But if you do think about the amount of data that they collect and the insight that they have in terms of the behavior, battery state of charge, what the resource is in real time, I think it's huge. And obviously, as we all know, data-driven techniques, data analytics, machine learning, all of those words in that language, I mean, are a growing feature for the work that we all do. So I think it's a big element of it. And I think the fact that they hold that data, and I think, I don't know, but I say when you buy a Tesla, I'm sure you're signing up to provision of all that data to them. I don't know that, but you'd imagine that's the case.
Mm-hmm. Very good. A slightly controversial question: are there any competitors who provide the same services as Novogrid?
Yeah, well, no, like, so I guess at our core, it's about network visibility. So there's a number of competitors, might be a strong word, but certainly, yeah, people who are providing and addressing this well-known challenge of providing the network status of these networks, which are poorly or sparsely instrumented. And I think our approach is unique and different. It's more of a software-based approach. Other people require hardware installation. I'm not really going to get into whether it's better or worse or whatever. So absolutely, the challenge we're addressing at its core of the visibility of the network is being addressed by a number of other international companies.
Very good. A question from Irene. How can operators generate profit and value in this system? Is it a safe investment nowadays?
I'm not sure what is meant by operators there, Albina, necessarily. In terms of, I guess, demands at aggregation, I don't know whether it's a safe investment, but certainly, I think what we're seeing in the energy markets is, increasing portions or pots of money set aside for system services. So for short-term power responses, reactive power responses, different types of, I guess, energy products. So the monetary value being put on them is only increasing. So I don't know whether it's a safe investment, but the trend would be that these kinds of services, which demand side can provide, are an increasing feature of the energy market and increasingly being valued higher, I suppose.
Very good. Yeah, Irene, you're very welcome to submit a follow-up question if you want to clarify anything further. And one more question from Andy: is the hydrogen the future or just a lot of hot air?
Okay, so I'm an electrical power engineer, so obviously I believe electricity is the solution to all problems. As I kind of alluded to earlier on, I think like electrification makes a lot of sense, but I think when you look at it, you're going to need other aspects. So maybe hydrogen as a technology isn't quite there yet, but I'm always mindful of, you could say the same about offshore wind and onshore wind, 10, 20 years ago. So I don't think it's a lot of hot air. I think there's a lot of potential within it, but I kind of have it in a 2030 and beyond side. But one point maybe to address that more fundamentally, which I would think about, would be, if you look at the amount of energy in potential in offshore wind, and in Ireland, as I mentioned, we have waters up in the Atlantic Ocean, and there are gigawatts of energy, far exceeding Ireland's national energy demand, and far exceeding maybe the current carrying or transmission capacity of HVDC cables, and also the distances. So I think actually, when we talk about net zero carbon, maybe we need to look at these kind of power to gas technologies and consider it. Now, it's a bit out there, but I think if you set net zero carbon as a challenge, then I think things like hydrogen could well have a significant role to play.
Very good. We've gone through most of the questions so far. So I suppose just a quick reminder, if anyone has any additional ones, you're welcome to submit them in the next few minutes. I suppose, Andrew, in the meantime, there are a few questions that we ask all of our speakers in this series. So I will kind of kick off with the first one. In your view, what are the biggest trends that we're seeing in the energy sector? What is already happening, and what do you foresee happening in 2021? I suppose kind of your talk already did answer to a certain extent that question, but is there anything you would add or expand on that?
Well, yeah, I guess I've talked quite a bit about that. But and again, maybe I kind of alluded to this, but and like, so fingers crossed, right? This vaccine from Pfizer really does work, and you know, it can be deployed and all of that. But hopefully, we can move to a post-COVID world. And I would imagine that when we do move to a post-COVID world, and I don't feel that the impetus has gone out of it, that, you know, we will be looking absolutely straight at the climate crisis as the defining challenge. With my university hat on, I deal a lot with students, as you might expect, and I've noticed a change in recent years with the students. So the younger generation, maybe 10 years ago or 5 years ago, yeah, climate was definitely consideration, but for them, there's almost an activism now in terms of like, this has to be addressed. This is an emergency. So I think, you know, this is only going to go up the agenda. So I think the trends are the trends, and albeit, but I kind of view that post-COVID, it's going to be front and center. We have the Green Party in a coalition government here now as well in Ireland, so it's certainly on the agenda here at the moment.
Very good. I can only hope you're right and it becomes more of an agenda worldwide, for sure. And I suppose kind of the last question I have, what is an impactful piece of content on the sector that you recommend checking out? So this could be a podcast, an article, book, study that you find impactful.
Oh gosh, I don't know. That's the hardest question of the day. I'm afraid I don't know offhand. I'm really sorry. Yeah, I'm generally reading all these academic papers and journal articles, so I'm not sure people would want to read them. So, gosh, I don't know. I'm sorry. Yeah, I'll have to pass on that one. Sorry, Albina.
That is not a problem. If you think of anything
I will. Yeah.
Further, we'll send it to everyone in a follow-up email.
Sure.
Fantastic. So I think at this stage we can probably wrap it up for today. So a huge thanks to Andrew for joining us, and a very, very interesting presentation. A huge thank you for all of our attendees for joining us today and for the interesting questions. And a quick reminder, this is the second webinar of a series on the energy sector. So we don't have the next one announced just yet, but it's coming in the next few weeks. So make sure to keep an eye on the Powering the Future series, and we hope to see you next time. Thank you very much, Andrew, once again, and I hope you all have a great evening.
Thanks a million. Take care.
Bye.